Hello and welcome to this Foundations of C video continuing on the topic of arrays. So last time we looked at the concept and syntax of arrays in C, and we finished up with this program here which has some buffer overflow problems. But if we just get rid of those problems for now, so let's actually only iterate up to 5 and let's access array element 4. Up here this is the syntax for declaring an array of 5 integers and we call that array numbers. So this is a fixed size sequence of numbers that we can manipulate. Following that integer array declaration we have a for loop here to accept input into each of our array elements. And then down here we just printf the last element in our array. And remember, array elements are 0 indexed. So by accessing the element with index 4, we are in fact accessing the last in our array of 5 elements. Now if you recall from the memory video, strings in C are just sequences of characters. And as such are typically stored as character pointers, just a pointer to the first character in this sequence. Because we only have a pointer to this first element though, to know how long the string is, we have to do what's called null terminating the string. We add this terminator character to the end, so people know where the end of the string is. Strings in C can also be stored in arrays though. And really this should come as no surprise, because as we've talked about previously, arrays and pointers are very similar. So the idea of strings in C still being pointers on some core level still holds up. So that then raises the question, why store strings in arrays? And the answer is that you may want to store strings in arrays if their values can change. For example, say we want to accept some string input from the user. When the user types whatever they want into our program, we can't just say, oh, this string must now be in our memory space somewhere, let's make a pointer to it. Because if the user has just typed it in, it's not going to be in our memory space yet. We can't just accept input into a pointer. We need to accept the user input into somewhere. We need somewhere to store that data. Just like how in this example here, we're storing data inside an array element, or how we scanf into variables. We can't scanf a string into a char pointer, because a char pointer just holds a memory address. It can't hold sequences of characters like we'd need it to. So let's go through some examples of holding strings in arrays. So first off, let's delete what we have here at the moment. And let's create a char array called string, which is 10 characters in size. Now we've declared this array of 10 characters, we can initialize its elements using the standard array initialization syntax. So we can write the assignment operator and then have some curly brackets. And in here we just comma separate the values that we want the elements to be initialized to. So in this case, let's say we wanted to construct the string hello followed by an exclamation mark. Then we might initialize these char elements to first off H, and then E, and then L, and then L, and then O, and then an exclamation mark, and then a null terminator. So if you think about it, if we had a pointer to the start of our array, this would be just like the C strings we talked about previously. And so if we call printf here with a %s format specifier, and we pass just, well, we can say string 0 address of, or we can just say string, because remember we have this duality between arrays and pointers. And we can save that and compile, and then run. And hey, it works just as you'd expect. An advantage of doing things this way though, is that we can then say, well actually, string 0 equals j or something like this, and then we can just printf the same pointer, and go back and compile, and run. And you can see we've told printf to output the same pointer, but because we've changed the value at that pointer, it outputs a different string value. So there we go, we've already demonstrated the advantage of working with strings in arrays. Before we move on to another example, there are a few more things I want to show you here. I bet some of you are asking, can't we just do this with normal strings in C? And the answer is no, you can't. So if I just go ahead and comment this out, and let's try the same thing using regular constant char pointers. So we're going to declare a char pointer called string, and we're going to initialize it to the value hello exclamation mark. And because that's a string constant, it's automatically null terminated for us. And then we'll just do the same things we did previously, so let's actually just copy and paste those lines. We'll do the printf. Then we'll try and modify the first element of our string to be a j, and then we'll do the printf again. And let's try it. So if we compile and we run, oh dear, this does not look so good. And of course the error we've made here is that you can't assume that you can modify constant strings in C. And in this case we definitely can't modify constant strings. So the problem here isn't that we're writing through a pointer instead of an array. In fact, what I can do if we just take this bit out for a second and we bring this back, and then we say this is string pointer and it points to the address of string 0, or in fact we can just write string here, and then we just change these to be string pointer. So what's happening here is we're still doing our write through a pointer, but we're doing it into our array, not into a constant string value. And if we compile and run, this one works correctly. So as I said, the real problem here is that we were trying to write into a constant string value. So if we just go back to our problem code here, there we go. If you remember from the memory video, I said that many implementations store constant strings in C inside the executable file. so that when the executable gets loaded into memory to get executed, we can just hold a pointer to the string inside our executable in memory. Most of the time though, this section of memory is marked as read-only, and so if we try to write into it, we're going to cause problems. I can actually show you that my implementation does this too, so if we just open up terminal here, and if we just compile the version that we currently have, so this is the version with the problems, the one that tries to write into a constant string, we can run a utility against our executable file to dump its contents in a more human-readable form. And so if I go ahead and do that, I'm using the objdump utility here, you'll see that actually there's a section of our executable file called cstring. And within this, lo and behold, there is our string, hello exclamation mark, followed by our null character. Funnily enough, we can also see our printf format string in here, %s, then a new line character, then a null character. However, if we go ahead and we comment out our problem version, and we comment in our array version, and we compile that, and then we can run the same utility against this executable file, and you can see now we don't see the string inside our cstring section, this typically read-only section. Instead, we can see it though inside this const section. Now I'm not entirely sure why that is. Given its name, I'm going to assume that the const section is also read-only, though I may be wrong, I'm not particularly familiar with this section. But if this is a read-only section, I would assume we get the value stored here purely to initialize our array. So we can use these values in memory to initialize our array elements to particular values, and then we can change those values at will, which is why this version works properly. So moving on from this example, let's just go ahead and get rid of all of this. Let's try and accept some input from the user. And as we've discussed, we can't just accept input into a pointer, and so we're going to accept it into a char array. So we're going to create a char array called input, and let's just say it can hold 256 elements. Why 256? Well, we don't know how long the string we want to accept from the user is going to be. And because arrays in C are of a fixed size, I'm just going to say that we can't accept any strings greater than 256 characters in length. Because if we want to accept string input into an array, we have to draw the line somewhere. So next off, let's have our scanf, and we're going to scanf using the %s format specifier into input. And remember, writing input like this is the same as writing address of input 0, so that's just going to read into our array. And remember, %s is the format specifier for a string value. So let's actually just say the user is inputting their name, so let's give them a prompt, input your name, and then we'll just echo it back to them. So we'll have a printf down here, your name is %s, and then we'll put their input into there. So we prompt the user, input your name, we then accept their input into our char array called input, which is 256 characters in length, and then we output the string your name is, and then whatever the user input to us. So we can try this if we go ahead and we compile it, and we run it, input your name, Joe, your name is Joe. So it works, and we can try again, input your name, Jill, your name is Jill. We are going to have some overflow issues with this though. What if the user tries to input a string longer than 256 characters? Well, to demonstrate this, let's reduce the size of our array to 16 characters. And if we compile and run, and then we input a value that is longer than 16 characters, like so, oh look, we have this problem again, like we did at the end of the first arrays video. This is a buffer overflow problem. And it turns out this actually isn't very easy to fix using scanf. And so the real solution is don't use scanf. Use some other function to accept input from the user, or write your own. This isn't super related to the topic of arrays though, so we're not going to talk about it right now. So something we could do with this kind of thing if we don't worry about the buffer overflows, is that we could make a basic login system. So the user puts in some username and some password, and if they match some hard-coded values, then we let them into some special branch of our program. So if we just delete everything we have here, and we create a username array which is 256 characters in length, and the same for the password array, and then we can just do our prompting and accepting input, so printf, enter a username, and we'll use one for enter a password. And then we will have our first scanf, which scans a %s into username, and we will do the same for password. And now what we need to do is actually do some kind of validation on the username and password. So presumably we're going to want some form of if statement here, and our else branch can be access denied. So really what we want to do here is we want to check if the username string is equal to some specific string value, and if the password string is equal to some specific string value. And of course we can't just write something like username equals root, because this is going to compare the pointers. It's going to check if the memory address of username is equal to the memory address of our constant string root. And that's not what we're interested in doing here. Really the way to do this is to compare the strings character by character. We could write something to do this ourselves, but it turns out there's a C standard library function to do this in string.h. So if we include string.h, and we go back down here, this function is called strucomp for string compare. So if we just go, okay, string compare, and we want to compare username to root, and it turns out this function actually returns 0 on success, not 1. So we can say, well, okay, if that equals 0, or what we can do instead is we can use this logical not operator. So if you recall, the logical not operator flips the truth value of the condition. So if the string compare returns a 0, we're going to end up with a 1. And if the string compare returns a non-zero value, then we're going to end up with 0. And for now, let's only check on the username. So let's just say printf access granted in this case. And by the way, you have to be careful with string compare, because if you don't set it up right, it will read off the end of your strings. But in this case, we're pretty safe. So if we go ahead and we compile this and we run it, enter a username, well, if we just try something that won't work, access denied. And if we try again, okay, let's use the username root and any password, access granted. So if we go ahead and check the password as well here, we can just use another string compare, and we can use the logical AND operator to bring together these two conditions. So we can check if the password is equal to, let's just say password. Not a very secure password, but what are you going to do? So we can compile and run, and we can try logging in with a valid username and an invalid password, access denied. And if we try again, and we go with the correct username and the correct password, access granted, it works. Now, this isn't a very secure login system for a number of reasons. This thing is vulnerable to timing attacks due to the way we're doing the string compare character by character. We shouldn't be storing passwords in plain text. Look up hashing and salting if you want to know a bit more about that. And hard-coded passwords sound like a bad idea anyway. Just to demonstrate some of these problems though, if we go ahead and run object dump again against our executable file, again we can examine this C string section, and we can see right there our strings for the correct username and password. So anyone that knows about this could inspect the binary and say, they're comparing with these string values, and then they can get access. Of course, if they have access to the executable, they could just change the instructions in there to branch to the access granted branch every time anyway. But that's a discussion for another day. What we could also do with this program is we can modify it to support multiple users with multiple passwords. So for example, we could have an array of char pointers, which is the correct usernames, and let's say we have 10 users or something like this, root, Joe, and so on. And we could also have a char pointer array of correct passwords. And this could also have, whatever, password, hello, and so on. So in this case, I'm imagining that the 0th element of the correct usernames array corresponds to the 0th element of the correct passwords array. And then we could use iteration to check if the entered username matches any of these usernames, and then if the password matches the one in correct passwords. Of course, it would still have the security problems that this basic program does here, but I'm going to assume you're not going to put this straight into some production environment. This isn't something we're going to do right now in the video, but I really do encourage you to do it in your own time. Now lastly, if we just get rid of this code we've written so far, we can also have multi-dimensional arrays in C. That is, arrays of arrays. So if you imagine a normal array just being a one-dimensional line of things, you could imagine an array of arrays being a two-dimensional table of things. Or an array of these, so an array of arrays, being this three-dimensional thing. So if we want to create a two-dimensional array, well, first of all, we need the type just as normal, so let's just say it's an int array. And then we have the name as normal, so let's call it table. And then instead of just having one set of square brackets here, we have two. And so we can say we want our table array to be 10 by 5, for example. And this means we have 10 lots of arrays of size 5. Integer arrays of size 5 in this case. And we can initialize these using a nested curly bracket syntax. So we can say, okay, assign that to, well, the first array should be 1, 2, 3, 4, 5, and the second should be 6, 7, 8, 9, 10, for example. And then we can say, okay, printf, and we want to printf an integer value. And that value is going to be, well, we want it off of our 2D table array. Well, okay, first off, which of the 10 arrays do we want? Well, let's just say we want the first one. And then which element in that do we want? Well, let's just say we get the third element in that. So that should be 3. And if we just copy and paste this, and let's get a different element. And let's get an element out of the second array of the 10. And we'll get the element with index 4, which should be 10. So we expect to see 3 and 10 here out of our two-dimensional array. So if we compile this and we run it, excellent, 3 and 10 is what we get. So a use for this, for example, might be if we wanted to pre-compute a multiplication table. So say that we decided that computing a multiplication table for some reason was quite expensive, so we're going to compute it once, we're going to store all the results in a multi-dimensional array, and then we can access them whenever we need them. Realistically, this probably isn't going to be a performance win for a small multiplication table, but never mind, let's just do it for now. Maybe in reality it's not actually going to be a multiplication table, but some other more complex calculation. So let's make our multiplication table. In fact, let's just get rid of all this first of all. Let's have a 2D array called multtable, and let's make it 12 by 12, because let's just say that's how big we want it to be.
And then we will do our calculation and initialization of our multiplication table. So we can have our outer for loop int I equals 0, I is less than 12, plus I. We'll then have our inner for loop, j equals 0, while j is less than 12, plus j. We then have our mult table ij equals I times j, and then actually we don't need any printfs here. So that should do the initialization just fine. If you think about it, we have an outer loop and an inner loop, and then we assign the slot in our table, if you will, in array I index j to the value I times j. So then if we wanted to do a printf down here, and we didn't want to do the multiplication for whatever reason, we want to use the result in our table, we can say, okay, printf the %d value in mult table 12, 12, for example. Maybe we should change that. Let's just change this to I plus 1 times j plus 1. So now mult table 12, 12 should give us the result of the multiplication 12 times 12, which should be 144. And if we go ahead and we compile that, oops, very silly mistake there by me. This is what happens when I try and talk while trying to code. This should, of course, be index 11, 11. And that should output 144. So if we recompile and we run, 144. And let's just try another one to make sure this works. So let's try something like 6, 1, which should be 7 times 2, which is 14. If we compile and we run, 14, it works. So that is multidimensional arrays. And indeed, that is the end of this video. Arrays are one of these topics that people can also get a bit confused about, so I'd recommend you really do practice and try and build something with arrays. In my opinion, making something is really the only way to learn it properly. Actually, writing code yourself is an excellent way of learning, so a few challenges for you that you might want to try. As we talked about earlier, some kind of login system that can accept multiple usernames and passwords. Or another challenge that I recommend you try, accept a string from the user into an array, and then reverse that string so the word program would become the word margorp, and output this reverse string to the user. So that is the end of this video. I hope you found it helpful, and I will see you next time.